Okay, so now let's see the last case for evaluating the limit where we have x approaches to positive or negative. X approaches to positive or negative infinity. When you substitute positive or negative infinity into your fx, you are going to get infinity over infinity, which we call this as limits at infinity for a rational function. So what are you going to do when you have this type of question? So here we are going to divide by highest power of the denominator. So what does it mean, power of denominator? So what does it mean by this? Let's see here. Okay, so we have case 5, limits at infinity for a rational function. So if you see, when we substitute the value of infinity into, first it must be a rational function. Okay, tahu tak rational tu apa? Rational is a fraction. Okay, so if you substitute infinity into here, macam saya cakap, if you substitute infinity into here, 2 times infinity, it is still going to be infinity. So here we are going to get infinity over infinity. So you know that this is a case 5. So what are you going to do is, we have to divide each term by x. Tak ada by x ni. Each term, divide each term by the highest power of the denominator. Okay, alright, divide each term by the highest power of the denominator. Okay, first, before we go to, okay, let's see example 12a first. Okay, so we have limit 2x cubed plus x squared minus 3 over x cubed plus x plus 2. First, when x approaches to infinity. So first, when you evaluating the limit, you have to make sure the x approaches to a constant or infinity. Okay, so here we have x approaches to infinity. So first, just try a substitution method. If you substitute into the infinity into x, into x, into x, into x, so you are going to get infinity over infinity. Okay, so this is infinity over infinity. So you know that this is a case 5, so you have to divide by the highest power of the denominator. So look at the denominator here. The highest power is x cubed. Okay, so what are you going to do is basically just divide each term. So first, write x approaches to infinity. Okay, so just divide each term, that means everything here, by x cubed. Okay, so we will have 2x cubed over x cubed plus x squared over x cubed minus 3 over x cubed over x cubed over x cubed plus x over x cubed plus 2 over x cubed. Okay, divide each term by the highest power of denominator. Jangan divide semua jangan buat x over x cubed. Okay, so this is easier for you to see how to evaluate the next limit. Okay, so now let's just simplify this. We have limit x when x approaches to infinity. So here we simplify x cubed, we can cancel. We have 2. Here we have cube 2. So we will have 1 over x here plus 1 over x minus 3 over x cubed over x cubed over x cubed. We still get 1. X over x cubed, we have 1 over x squared. And here we still have 2 over x cubed. Okay, so now we are going to do back to our case 4 and case 1. So here we have limit x approaches to infinity. Okay, case 4, basically case 4 lah. Limit x approaches to infinity 2, a constant. So that still gonna be 2. Okay, so sekarang kita dah substitute the value. You can hilangkan limit kita. So now substitute infinity into here. So we will have 1 over infinity. So case 4, 1 over a constant over infinity, you are going to get 0. Okay, so here substitute infinity here over here, 3 over infinity, still get 0. Here is a constant, infinite x approaches to infinity, a constant, so doesn't affect anything. So here still be 1. So here is 1 over infinity, so this will be 0, and this one also will be 0 plus 0. So the final answer here will be 2 over 1, which is we get 2. So that is how you find a limit at infinity for rational function. Okay, so just divide each term by the highest power of the denominator. Okay, so let's see the next example, example B. Okay, before we proceed to the next example here, okay, I would like to remind you what is the definition of square root x square? Okay, or a modulus x, the same thing. Modulus x is a square root x square, which is the definition is we are going to get positive x and negative x. Okay, so we know that this is x greater and equals to 0, this is x less than 0, and we know that x greater and equals to 0 is for x approaches to positive infinity, and x less than 0 is for x approaches to negative infinity. So this is the definition that you have to know. Okay, alright, so let's see example B. Okay, this is a special case. Okay, so what does it mean? Why I call this as a special case? We still have to, okay, first we just substitute the value of infinity. So here we have negative infinity. If we substitute infinity here, we still get infinity. The numerator, you still get infinity. The denominator, you still get infinity. So here is a case for, okay, but you have a square root here. Okay, as you can see, a square root here. So before we divide by the highest power of the denominator, we have to do something. Okay, we have to simplify the square root first. Okay, so this is a special case lah. So what are we going to do is, basically we have to take out square root x square from the denominator. So how to do that? So we will have limit x approaches to negative infinity, numerator, doesn't matter, okay, x plus 1. Alright, so now we have to factorize square root x square from the denominator. So we will have square root x square, square root, okay, so take out x squared, here we have 1, and take out x square from here, we will have plus 1 over x square. Okay, so make sure kalau nak check balik, kita darab balik semula lah. X square times 1, we get x square. X square times 1 over x square, kita dapat 1 dekat situ. Okay, so now you have to check your limit x approaches to negative infinity. So usually for a limit at infinity for a square root, the limit mesti akan kata positive or negative infinity. Okay, so for this one, the answer should be the same, doesn't matter, sebab kita punya jawapan masih lagi sama. Okay, tak ada yang berbeza. So for square root, maybe akan berbeza untuk positive infinity or negative infinity. So now, as I said earlier from this definition, where when we have x approaches to negative infinity, the answer is negative x. So you are going to turn this, change your square root x square into negative x. Okay, so here we will have limit x approaches to negative infinity, x plus 1. So square root x square, since the limit is x approaches to negative infinity, we are going to change this into negative x. Okay, yang dalam jangan usik, biasa saja. 1 plus 1 over x square. Okay, now just do the same, which is we are going to divide by highest power of denominator. Divide by highest power of denominator. Alright, so now what is the highest power of the denominator? Okay, common mistakes here, the highest power is not x square. Here is x negative 2. Okay, x negative 2. So this is not the highest power. The highest power is actually x. So we are going to divide everything with x. So we have limit x approaches to negative infinity. So x over x plus 1 over x over, also the denominator we are going to divide by the highest power, but only for the outside one here. Okay, ini tak perlu usik, sebab once you divide by x dekat sini, maksudnya kita dah divide yang dekat dalam lah. Okay, so dalam jangan di-divide lagi. So here we still have 1 plus 1 over x square. Okay, so now let's simplify this. We are going to get limit x approaches to negative infinity, 1 plus 1 over x. So here you are going to get negative, x over x is 1, so negative 1. 1 plus 1 over x square. So now we can simply substitute the value of infinity. Negative infinity, 1, we are going to get 1. Negative infinity here, 1 over 0, we are going to get 0 over negative. So here is still 1 plus 0, and the final answer should have, we have 1 plus 1, 1 over negative square root 1 is basically 1. Okay, sorry, negative 1. Negative 1. Okay, so that is your final answer. So what is the special case for limits at infinity? Basically, we have to take out square root x square first. Okay, basically factorize square root x square and determine it is positive x or negative x by looking at the limit here. X approaches to positive, negative, infinity. Okay, so let's try one more question here. Let's see if we have limit x approaches to positive infinity, square root x square plus 4 over x plus 3. Okay, so the same thing works here. First, you have to, tak kisah if it is dekat numerator or in the denominator, you still have to take out square root x square if the question has square root. Okay, so now this is a special case, so we have to factorize our square root x square first. Okay, this is very important. X approaches to positive infinity. So factorize square root x square, so the inside will be 1 plus 4 over x square. Okay, check back. X square times 1, we get x square. X square times 4 over x square, we get 4. Okay, over x plus 3. Okay, so our square root x square here, we are going to put as positive x, since x approaches to positive infinity. X approaches to positive infinity, so we are going to get positive x. Okay, saya tulislah kalau kamu tak faham. Since x approaches to positive infinity, square root x square is equals to positive x. Okay, so here we are going to change square root x square into positive x. So yang dalam jangan usik, we will still have 1 plus 4 over x square over x plus 3. So here we just go back to the original problem, which is divide by the highest power of the denominator. So here we will have limit x approaches to positive infinity. So we have x over x square root 1. Yang dalam jangan usik, macam saya cakap, this is actually a factorization. So once you divide by x here, it's actually divided also. Okay, so over x over x plus 3 over x. Okay, the highest power of the denominator yang ini x. Okay, so jangan kisah yang numerator. So the highest power of the denominator is x. So here you are going to get, just simplify the answer here first. We have limit x approaches to positive infinity. Here we are going to get 1. So numerator we left with 1 plus 4 over x square only. The denominator we have 1 plus 3 over x. So now we can substitute the value of infinity, which is we have 1 plus 0 over 1 plus 0, and your answer should be equals to 1. Okay, so that is your final answer. Okay, I would like you to try question D. We are going to discuss this in the class next. The answer here is negative 2 over 3. Okay, so please try question D, and here is your exit ticket for this today's class. Okay, so kau tak nampak. Alright. Okay, both are limit x approaches to positive and negative infinity. Alright, thank you class.